Okay, we're going to start the dreaded integration. So if you have the SIA notes up, the first wee bit is finding the area between a curve and the x-axis. See, before I even go there, can I remind you how to integrate, or what integration is? First of all, I'm going to look at differentiation. If you had an expression like this, and you had to differentiate it, you would move the power to the front, take one off, the x disappears, and the constant on its own disappears. Now, remember, integration is the reverse of differentiation. So, you follow these rules. Instead of the power going to the front and subtracting 1, you add 1 to power, and divide by it. Okay? And when the x disappeared to give you a number, the reverse of that x will reappear if you have a number. So if number on its own, x will reappear. And remember, the constant disappeared when you differentiate it, so it reappears when it integrates, when you integrate back, and the constant reappears. But you don't know what it reappears as, because it's disappeared. You can't just say it was a 3, because you don't know it was a 3. You write plus c. So if I take that wee example I have above there, this is it in its differentiated form. If I want to go back, that's the power of 1, add 1, divide by it. The x reappears, and don't forget your c. So you get back to 3x squared plus 2x plus c. So you can't figure out that 3. Remember, differentiation can be written like this: integral sign 6x squared add 2 dx. You must have the integral sign, and you must finish it with dx, and everything in between you integrate. So you add 1 to that power, divide by it. X reappears, and don't forget your c. And that's recapping over the basics. Other one I want to talk to you about is definite integration. That means you've definitely got values for it. And it's the one that looks like this. Integrate 1 to 3 of, let's go for 6, let's stick with the same sum. So in this one, you do your integration of that bit as normal. You don't have to put the plus c in, you can if you want, but I'll show you what happens to it if you don't put it in. Upper integral limit, lower integral limit, so it's 2x cubed plus 2x plus, oh yeah, I was just checking there, I started off with a different one, that's what the difference is there, plus c, 3, 1. So you sub in your 3, so x equals 3, you sub it in. I use curly brackets when I sub it in, so it's 2 times 3 cubed plus 2 times 3 plus c, and then you sub in your lower limit of 1, so x equals 1. So it's 2 times 1 plus 2 times 1 plus c. So the first bracket becomes 54 add 6 is 60 add c, and the second bracket becomes 4 add c. 60 take away 4 is, 60 take away 4 is 56, and the c's disappear. So you don't need to include the c's whenever you're integrating, definitely. Now, let's have a wee look. We're looking at areas here in the first section. Area between the curve and the x-axis, so that's this one. You integrate the curve, so integrate the curve, now y is a curve, between your first x and your second x. So that's all there is in that. You'll see it through the example, it's not too bad. Just be careful if they want you to integrate against the y-axis. This time you're integrating the y's. So see up here, you're integrating the x's, integrating the y's. Up here you'd y as your curve. This here you have to have x as your curve. And then it's your y values running for your integral sign. So let's see what that means. Your first wee example is integrate this curve. Between the curve, the x-axis, and the line y equals 8. That's an x cubic curve, so that's it there. The line y equals 8 goes through the x-axis 8, and I want the area between this and the y-axis. Before I do that, I'm just going to show you what would happen if I wanted it between the curve and the x-axis and the line x equals 8. So what I'm doing here, I'm doing the same question, but I'm going between the curve, the x-axis, and the line x equals 8. Just to recap your memories here. So you're integrating from 0 to 8 of the curve, dx. So 0 to 8, y equals x cubed dx. So you add 1 to the power, divide by it. Whether you put the c in or not is irrelevant, that's up to you. Put in the 8, so it's 8 to the power of 4 divided by 4, take away, putting in the 0. So you just on your calculators, 8 to the power of 4, take away 4, gives me an area of 4092. But this question wanted me to integrate curling up to the y-axis, was this area. So the area is integrating the y's. So I write dy. So x must go in here. I've got y equals x cubed, but I need to put x in there. So if you bring this over to the far side, it's the cube root. And the cube root can be written as the power of a third. So this here is y to the third dy. And my limits are not up to 8. So you add 1 to the power and divide by it. 8 and 0. So dividing by a fraction seems turning upside down. That's the cube root of y. So it's going to be the cube root of y. I'll just do it in 2 stages. So subbing in your 8, the cube root of 8 is 2. And then it'll be 2 to the power of 4, 16 divided by 4 is 4, times 3 is 12, take away, sub in 0. So it is 12 units squared. That's basically what was going through there. So hopefully doing it, first of all, normally by the x-axis and then by the y-axis will help you a wee bit in there. Okay, next wee section of your notes, quite a bit here. Area between the line and the curve. I've written down there you must find the intersection points first and drop down any verticals. Okay, so what do I mean by that? Area between, I want to find the area between this line and this curve. There's my x squared curve. That line has got a gradient of -2 and it goes through the y-axis at 3. So 3, and that's my line pointing down. First, I must find any intersection points. So to find your intersection points, you put the curve equal the line. This is a quadratic, so put everything on one side. Just factorize or use the formula. And you find the intersect when x is -3 and x is 1. So what I'm going to do now, if you can see where the pen is, I'm going to find the area under the straight line. Now you can either integrate like I've done there, or you can write it as trapezium, it's up to you. I find it's easier to integrate. So I'm integrating under the line. Then I'm going to take away the area under the curve. That's what I'm doing here. So the area under the line, integrate the line, then I'm going to sub in 1, I'm going to sub in -3. Take away. Area under the curve is x squared, integrate it, sub in 1, get that, and sub in -3 to get your answer there. And then you just subtract those, and you should be there for 10 2/3. The last one I'm going to look at here, now do take your time with these please. Area between the curve x cubed, there's there, and 2 minus x squared. Remember an x squared curve is just that shape, so you're lifting it up 2. Okay. The most important thing is finding the intersection. Always do that. So put the curves equal each other. You've got a cubic, everything on one side. And this is really difficult. Do you remember how to solve a cubic? You have to start guessing. I wrote, right, fx equals your expression. Try 1. So put 1 in, and that worked out quite nicely. So x equals 1. That means, if you remember this, x minus 1 is a factor. Then you've got to divide through by x minus 1, all that rigmarole. That's we 0 there. So fx is the divisor times the top line. You're trying to find, if you look back at what you're trying to do, you're trying to solve this equaling 0. So put this equals 0. So they intersect x equals 1. There's my first one. And for this one doesn't factorise, so try the formula. You will see you've got a negative root, so 4 minus 8 is minus 4 in there, so it's a negative root, so there's no solution. So they meet the ones. Right, I've got the intersection point here. To find the area between the curves, at this point, you're going to find the negative area, or the negative curve first. So it's 2 minus x squared, running from 0 to 1. So that will get you the area under this bit. Then you're going to take away the area under the x cubed curve. So do your wee integration for the x squared curve. And do your wee integration for the cubic. Sub in 1, sub in 0, sub in 1, sub in 0, and get your answer. You'll notice I do tend to do them out separately.